in terms of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers. There you will find not only this, but similar type of so many entrance exam question papers for your practice. For a better preparation of your exams, you must download our app. The link is available in the description box. So students, today we'll be solving the chemistry section for the AP EPCET 15 May 2023. Shift 1 paper. I'll be solving the chemistry questions in this video. So very best of luck. Here we go with the question number 121. It's a Vijayawada FM radio station broadcast at a frequency of 103.4 megahertz. The wavelength of the corresponding radio waves in meters is. So actually this is pretty easy. You are given that the frequency is this much megahertz. If I write it in the normal form, this is 103.4 mega is 10 raised to power 6 normal hertz. So what do you have to find out? You have to find out the wavelength. Using the formula, C is equal to frequency into the wavelength, or wavelength is equal to C upon V. You have C is the speed of light. So here you have 3 to 10 power 8, 103.4 into 10 power 6. This will give you 0.029 into 10 power 2 meters, or this is equal to 2.90 meters. That makes option A to be the correct answer. Hope you understood that. Let's move to the next question. Question number 122. The minimum number of quantum numbers required to specify an orbital in an atom is. See, the number of quantum numbers required to specify an orbital number in an atom is 3. These are principal quantum numbers which are given by M, N, L, and M. This represents your principal quantum numbers. This is your azimuthal quantum numbers. And this is magnetic. Quantum numbers. That makes option D to be the right answer. Super easy. Next is question number 123. Consider the following two statements. First says, among magnesium, aluminium, magnesium ion, and aluminium ion, the one having the smallest size is aluminium ion. And the statement 2 says, EU is having exceptionally high atomic radii than lanthanide elements. Question number 123, consider the following two statements. First statement says, among magnesium, aluminium, magnesium ion, and aluminium ion, one having the smallest size is aluminium ion. And the statement 2 says, the europium is having exceptionally high atomic radii among all the lanthanide elements. What is the correct answer? See, if I check out the first statement that says that among all of these, the smallest size is having aluminium ion is having the smallest size. One thing, higher the cationic charge, like aluminium is having a charge of 3 plus over here. Higher is the cationic charge, smaller is the ionic radii due to the increase in the effective nuclear charge. As we move from left to right in the period, ionic radii decreases. So what will be the correct order? Correct order will be given by, this is the smallest one, then the magnesium ion will have the bigger radius than this one, then is aluminium, and then is the magnesium. Okay, so that makes first statement to be the correct one. Second, it says that europium is having exceptionally high atomic radii among all the lanthanide elements. That is absolutely true. See, europium with the atomic number 63, this is readily reactive in the air. And it's a very soft metal which can be even cut down with the knife. And yes, it is having the very high atomic radii among all the lanthanide elements. That makes the second statement also to be true. So you have option A as the right answer. Hope you understood. Next is question number 124. Identify the pair of elements with the highest and the lowest electronegativity respectively. Electronegativity, what is that? electronegativity negativity increasing on moving from left to right in a periodic table, and it decreases on moving from um okay, it decreases moving down the group. Okay, thus fluorine is having the highest electronegativity and francium is having the lowest electronegativity, right? So this is the right answer. Option C is the correct one. Hope you understood that. Let's move to the next question. Question number 125. If the bond order of C2 is X, then the bond order of B2 and O2 respectively are which of these options? See, C is having 6 electrons, so C2 will have 12 electrons. The electronic configuration of a C2 is given by this less than. So this is the electronic configuration of C2. That is by 2 pi 2p x square, which is approximately equal to pi 2p y square. So if the bond order will be, so what will be the bond order from here? Bond order will be equal to NB minus NA upon 2, which is 8 minus 4 upon 2, or that is 2, which is your X. So that means the bond order of C2 is equal to 2. Now, the electronic configuration of B2 is given by this. This is the electronic configuration of B2, right? Which is approximately equal to pi 2 y part 0. So B is having 5 electrons, B2 will have 10 electron, B is having 5, so B2 will have 10 electrons. What will be the bond order of B2? This will be 6 minus 4 upon 2 is equal to 1 is equal to X by 2. Similarly, O2 will have 16 electrons, and its bond order will be given by 10 minus 6 upon 2, which is equal to 2. So this is your X now. This is equal to X, right? So the bond order of B2 and O2 respectively are X by 2 and X. That makes option C to be the correct answer. Hope you understood this. Let's move to the next question, number 126. Identify incorrectly matched set from the following. First one, molecules with the incomplete octet, BeH2 and BCl3. No, this is absolutely correct. This is correct. Next, polar molecules, they are BF3 and CCl4. CCl4, that these are polar? No, they are non-polar molecules. So this is the right answer. This is the incorrect matched pair. Option B is the correct answer to the question because this is wrong. Next is question number 127. An ideal gas X present in the vessel of volume VL exerted a pressure of 16.4 atmospheres at 200 Kelvin. What is the concentration in mole per liter? Okay, this is liter. So now you're given, let's write down what you're given. The pressure is 16.4 atmospheres and the temperature is 200 Kelvin. And the what else is given to you? R is this liter atmosphere per mole per Kelvin. So volume is V, it's L actually, it's like this. So this is volume. Using ideal gas equation to find the number of moles using ideal gas equation. To find the number of moles, you have PV is equal to nRT. So N is equal to PV upon RT. This is equal to 16.4 into V upon 0.082 into 200. On solving this whole thing, you will get this is equal to 1B. So number of moles is equal to 1B. Now using formula for molarity, you have a molarity is equal to number of moles of solute divided by volume of solution in liters. Right? So this is 1V upon V, so that is equal to 1. So 1 mole per liter. This is the molarity. That is option C is the correct answer. Hope you understood. Next is question number 128. A 100-liter cylinder containing hydrogen gas exerted a pressure of 4 atmospheres at 300 Kelvin. It was accidentally opened and some hydrogen was escaped. When it was closed, it exerted a pressure of 3 atmosphere at 300 Kelvin. The number of hydrogen remaining in the cylinder is equal to. Okay, so here you have to assume that hydrogen is an ideal gas and R is equal to the gas constant. Fine. So when the cylinder is closed, then I'm writing down the values of that. When cylinder is closed. So you have pressure as 3 atmospheres, temperature is 300 Kelvin, and the volume is 100 liters. Right. Okay. So now the gas constant is R. This is your gas constant. So you have to find out your N. Now again, I'm using the equation PV is equal to nRT. The pressure was equal to 3 atmospheres, volume was 100 liters, and we have to find out R is your gas constant, and the temperature was equal to 300 Kelvin. So these two things will cancel, or you will have N into R is equal to 1 or N is equal to 1 by R. That makes option C to be the right answer. Hope you got that. Next is question number 129. It says, observe the following reaction that chlorine is reacting with the chlorine gas is reacting with 2H negative OH hydroxyl ion aqueous to give you this plus this plus this. You have to identify the correct statements about the reaction. First one, it says the chlorine is oxidized to this aqueous. See, from the above reaction, it is very much clear that chlorine gas is oxidized to this ion, and chlorine gas is reduced, itself gets reduced to chloride aqueous. Okay, so that makes first one is correct. It is oxidized, and the last one, chlorine reduces to this. So you have 1 and 4 as the correct answers. Option A is the correct one. Here, this is being oxidized and chlorine is being reduced. That's it. See, oxidized, that means it is losing one of the, sorry, it is gaining one of the oxygen atoms, and the negative charge is being introduced over here. Question 129, observe the following reaction and identify the correct statements about the reaction. So the reaction is chlorine plus 2 hydroxyl ions aqueous chlorine gas and 2 hydroxyl ions aqueous gives you hypochlorite aqueous chloride action ion aqueous and the water as the liquid. So the first one says chlorine gas is oxidized to hypochlorite aqueous. This is absolutely correct. See, what do you mean by the oxidation and the reduction? Oxidation says when electrons are removed. Electrons are removed or oxygen is added. And the reduction is the opposite of it. It says when the electrons are added or oxygen is removed. So first one, chlorine gas is oxidized to this. This is absolutely correct because here the chlorine will be, this will have the positive charge and O is having one negative charge. So that means this is absolutely correct. The chlorine is getting oxidized to give you hypochlorite ion. Here chlorine is having a positive charge. Okay. All right. So this is overall negative because one positive will have, because oxygen is having two negative. Okay, leave it. Anyways, the second one, the chlorine gas is reduced to chloride aqueous. This is the last one. C part is also clear, right. The chlorine gas is reduced to give you, because here the electrons are being added to it. So this is reduction. That means option A is the right answer. Hope you understood this. Next is question number 130. If the standard enthalpy change of given for a certain reaction is 298 Kelvin and the constant pressure is given by this, the standard entropy change of the same reaction is given by this. Which of the following statements is correct? Let's write down first. So you have the standard enthalpy change as this. Standard enthalpy change is minus this much kilojoules per mole, and standard entropy change, which is given by this, is equal to minus 550 joules per Kelvin per mole, right? So delta G is given by delta H minus T delta S, or here you have minus 1860 minus 298 into minus 0.5 into 0.55. So this is equal to minus 1860 plus 163.9, or this is minus 1696.1 kilojoule per mole. Since the value of delta G comes out to be negative, thus the reaction is spontaneous. Spontaneous also, for the spontaneous reaction, delta S should be positive. Thus options okay, thus option C that gives you this equation. The reaction is positive, this spontaneous. This is absolutely correct. So this is the right answer to the question. Next is question number 131. If the standard enthalpy change for this reaction is given by this, and the standard enthalpy formation of this in, okay, you have to find out the standard enthalpy of formation for HBr in the gas. So hydrogen bromide gas in, you have to find out the standard enthalpy formation for this. So here the reaction will be something like hydrogen plus bromine will give you 2 hydrogen bromide. This is in the gaseous form. This is also gas, and this is liquid. So standard enthalpy change is equal to minus 72.8 kilojoules, and you have to find out standard enthalpy of formation. This is what you need to find out. Okay, now this is given by half of this. Standard enthalpy of formation of hydrogen bromide is given by half of this. So you already have got this minus 728 divided by 2. This is equal 0.8. This will be equal to minus 36.4 kilojoules per mole. This is the answer to the question. And you have option A as the right answer. Hope you understood this. Next is question number 132. Question number 132. At temperature T in Kelvin, the equilibrium constant for this reaction is 10 power minus 2. The rate of the forward reaction is given by this. The rate of the backward reaction in mole liters, these units are a bit wrong. This will be mole per liter per second. So, you know one thing, that the equilibrium constant is given by the forward rate reaction divided by the backward rate reaction. Reaction rate of a reaction. So this is 10 power minus 2. This is equal to, forward one is given to you as 0.025, and the backward one, I don't know, I have to see that. So KB is equal to 0.025, which is equal to 25 upon 1000 into 1 power 1 upon this. So this becomes equal to 25 upon 1000 into 100. This is equal to 2.5 mole per liter per second. So actually this is not in the options, in any of the options. So none of these. right? Next is question number 133. 1 mole of water gas in the gaseous form and 1 mole of carbon monoxide in the gaseous form are taken in 1 liter flask and heated to 725 Kelvin. At equilibrium, 40% by mass of water is reacted with carbon monoxide gas as following. Its Kc value is, okay. So here you have the volume as 1 liter is given, and let's say the volume is equal to 1 liters, and the temperature is 725 Kelvin. The equilibrium reaction will be given by water plus carbon monoxide. It gives you hydrogen gas and carbon monoxide gas. And this is a forward and backward this reaction, and this is the equilibrium reaction. So initial moles, let's say for water, here you have carbon monoxide, hydrogen, and carbon dioxide. Initial moles are, for water you have 1 this much, and the change comes, see, after I have balanced it, the change is minus 0.4 minus 0.4, these two will be gained. So moles at equilibrium will be moles at equilibrium 0.6, 0.6, 0.4, 0.4. So the expression for the equilibrium constant Kc is given by 0.4 into 0.4 upon 0.6 into 0.6. This is equal to 4/9, or that's equal to 0.444. That is option A. Hope you understood that. Next is 134 question. The OH bond length in water in gas phase is given by. In the gaseous phase, the water molecule has a bent structure with the 104.5 degree. Bent structure, water molecule has bent structure with this much degree bond angle. The OH bond length is 95.7 pm. So the structure of water, it's something like this. Here is O, here are two hydrogen atoms. This angle is 104.5 degrees, and there are two electrons over here. So this is 95.7. Okay, so I think this is it. You have option A as the right answer. Hope you understood that. Next is question number 135. Which of the following alloys are correctly matched with their uses? First one, lithium, magnesium, armor plates. Okay. Then carbon, sorry, this is copper and Be, beryllium, high temperature, high strength, sorry, I'm repeating this. Which of the following alloys are correctly matched with their uses? First one, lithium and magnesium armor plates. Copper and beryllium have high strength springs. Magnesium, aluminum, aircraft construction. Actually, all these are correct. All the alloys are correctly matched and their uses. Lithium, magnesium is used in the armored plates. Copper, beryllium in high strength springs, and magnesium, aluminum in aircraft constructions. So the option is the correct one. Next is question number 136. You have to match them. So list one, group 13 element, and list two, metallic, radius, and PM. Okay. So group 13 elements, you have first of all aluminium. Aluminium is question number 135. Which of the following alloys are correctly matched with their uses? Lithium, magnesium, armor plates, copper, beryllium, high strength strings, magnesium, aluminum, aircraft construction. Actually, all these are correct. All the alloys are correctly matched. Lithium and magnesium, they are used in armor plates, copper and beryllium, high strength springs, and magnesium and aluminum are used in aircraft construction. That makes option D to be the right answer. Hope you understood this. Next is question number 136. So you have to match the group 13 elements. The name of the elements are given to you, and these are given the metallic radius of those elements in picometers. Let's read. So first one is aluminium. Aluminium is having the metallic radius of 143. picometers. And the next one is gallium. Gallium is having the radius of 135 picometers. Then you have this is lanthanum. This is having 167 picometers. And the last one is thallium. Thallium is having obviously 170 picometers. So this is the correct answer to the question. That makes option B to be the right answer. Hope you got that. Next is question number 137. You have to choose the acetic oxide from the following. The first one is carbon monoxide. No, this is not acidic. The next one is GeO. This is acetic oxide. This is germanium oxide. This is acidic in nature. The next one, tin oxide and lead oxide, they are amphoteric oxides. And this is neutral. So that means germanium oxide, this is acidic in nature. Option B is the correct answer. Hope you got that. Next is question number 138. In the Kolbe electrolysis of the sodium propanoate, the products X and Y are formed at the respective electrodes. What are the X and Y? Okay, so first of all, sodium propanoate, this is given by 2CH3, CH2, COONA. This is sodium propanoate. This when the electrolysis of this is done, so this is reacted. Electrolysis is done in the presence of water. This will give you this product, these two ions, sodium ion. So here is two. Okay, now at anode and cathode, first of all, I'll talk about the anode. Anode, you will have CH3, COO, CH3, CH2, COO. This will give you CH3, CH2, COO plus electron. Plus one electron on, if I subtract like one carbon dioxide is removed from it, you will get this radical, ethanol. Okay, now the radical formed over here undergoes dimerization. So you have CH3, CH2, here is one electron, plus CH2, CH3, here's another electron, and here was also one electron. So this gives you CH3, CH2, CH2, CH3, which is butane. Right? That was your at anode. And what happens at cathode? At cathode, first of all, water, two electrons are added to give you hydroxyl negative plus hydrogen ions. Let's do the balancing. You will have a 2 and 2. So these two hydrogen ions, they will give you hydrogen gas. Also, the two sodium ions, they are mixed with two hydroxyl ions to give you sodium hydroxide. Two molecules. Thus, the water molecules undergoes reduction to give hydrogen gas at cathode. Water molecules undergo reduction to give you hydrogen gas at the cathode. Thus, what are your X and Y? So X is CH3, CH2, CH2, CH3, which is your butane, and Y is the hydrogen at anode and cathode, respectively. Okay. So let's check with the options now. You have third option as the right answer. Hope you understood this. Next is question number 139. Which of the following molecules is not aromatic? So you have given four options and you have to find out which one is not aromatic. See, when a compound is said to be compound or a molecule is said to be aromatic, if it is planar and follows Huckel's rule and there is complete delocalization of pi electrons. Right? So among all of these given options, the option D, which is having 1,3,5 cycloheptatriene, is not a planar molecule, and complete delocalization of pi electrons does not take place in this. Therefore, this is not aromatic, and option D is the correct answer. Hope you got that. Next is question number 140. An example of network solid is out of these four, which is the correct one. See the first one. Among the following options, the silicon oxide is an example of network solid. That makes option A to be the right answer for sure. Simple. See, network solids are an array of network solids. They are an array of repeating covalent bonded atoms. And the covalent network solids, they are like the giant covalent substances, which can be like your diamond, graphite, and your silicon oxide. So we have option A as the right answer. Next is question number 141. 20 ml of 0.1 m moles of hydrogen chloride is added to 30 ml of zero point 0.1 moles of this much sodium hydroxide. To this solution, extra 50 ml of water was added. What is the molarity of the final solution formed? Okay, see, first of all, let's write on the reaction. Hydrogen chloride is made to react with sodium hydroxide. The products will be sodium chloride and water. If I talk about the number of moles, the number of moles remains same on both the sides. That is M1, V1, and here is M2, V2. They will remain the same. So you are having 20 ml of 0.1 mole of this. So 20 ml of moles are 0.1, volume is 20. This is on this side, you have 30 ml of 0.1 again. So here is 30 ml of 0.1, right? So how many moles are there? Here are 2 moles, and here you have the 3 moles. So from the reaction, it is clear that 2 moles of hydrogen chloride will react with the 2 moles of hydrogen chloride will react with the 2 moles of sodium hydroxide to give you 2 moles of sodium chloride, and the remaining 1 mole will be involved in the formation of water, and 1 mole of water. Thus, the remaining 1 mole will be involved in the formation of water. So the final molarity of water will be equal to 0.01 m. That makes option B to be the right answer. Next is question number 142. Molarity of one model glucose solution having the density given by 1.2 gram per milliliter is. So you have the molarity of one model glucose solution. Molarity M is equal to 1 m, and density is given by 1.2 gram per milliliter. Molarity capital M you have to find out. This is given by M into rho upon this. So let's say this is equation 1, where this is molality. Sorry, I wrote molality. And this is your molarity. M2, molar mass of glucose. And this is your density. So let's substitute all the values in this equation 1. You will have M is equal to 1000 into 1 into 1.2 upon 1000 plus 180, which is 1200 upon 1180, or this is equal to 1.01 M. So the right answer to the question, option B is the correct answer. Hope you got that. Next is question number 143. The conductivity of a solution containing 2.08 gram of anhydrous barium chloride in a 200 ml solution is equal to this. The molar conductivity of the solution in per ohm centimeter square per mole is x into 10 raised to power 2. You have to find out the value. The value of, I think you have to find out x. Okay, so you are given the atomic mass of barium is this and chlorine is this. Let's go. First of all, mass of barium chloride given as 2.08 gram, and the molar mass of it, molar mass of barium chloride is equal to 208 gram. Right, because see, this is barium chloride. Barium is having 137, so 2 atoms of chlorine will be 70. The total is equal to this is 71, sorry. Okay, 208 grams. So the volume of solution, 200 ml or 0.2 liters. Conductivity is given by 6 into 10 power 3 minus 3 per, ohm. So per ohm per centimeter. Molar conductivity is molar conductivity is x into 10 power 2 per ohm per centimeter per mole. So this is equal to 10 into x into 10 power 2. Okay, fine. So molar conductivity is given by this only. You have to find out the molar conductivity, and the formula is given by molar conductivity is equal to conductivity multiply 1000 upon m, where m is your molarity. This is equal to 6 into 10 power minus 3 into 10 power 3. And molarity, this is, what is molarity equal to? 2.08 upon 2.08. And here is 0.2. Okay. So this is equal to x into 10 power 2. Let's solve this. See, molarity is equal to number of moles upon volume. So number of moles upon volume, number of moles, this is equal to given by this. So number of moles will be given by 2.08 divided by the total molar mass, that is 208, divided by the volume, which is equal to 0.2 liters. Okay, now let's get back. You have x into 10 power 2. Let's write it again. You have 6 into 10 raised to power minus 3 into 10 raised to power 3 into volume, which is 0.2, divided by 2.08 upon 208. This will cancel at 0.0001. And on solving, this will be giving you 1.2 into 10 power 2. This is equal to x into 10 power 2. That means x is equal to 1.2. So you have option A as the right answer. Hope you understood this. Let's move to the next question. In this question 144, for the reaction A plus B gives you C, the following data is obtained, that the initial concentration of A in moles is this is the molarity, and for B, this is the data. Initial rate in molarity per minute is equal to what? Okay, so if you have the reaction, this is the given reaction. Rate is given by constant into A's concentration, B's concentration. So the rate R is equal to K into A power is concentration power X, B's concentration power Y. This is given to you as in the first one, 1.04 into 10 power minus 3. This is equal to K into, this is 0.1, this is 0.1. So 0.1 power X, and this is power Y. Let's say this is 1. So, okay, fine, this is power 1, and Now let's go for the second one. This and this. So for the second one, you have 9 into 10 power minus 4 is equal to k into 0.1 power x, 0.3 power y. And let's say this is second. And the third one is this 2.7 into 10 power minus 3 is equal to k into 0.3 power x, 0.3 power y. Let's say this is third equation. So using the first two equations, equation 1 and 2, equation 1 and 2, what you get is dividing both of them. You have 9, or you can say dividing them. 9 to 10 power minus 4 upon this is equal to k into 0.1 power x, 0.3 power y upon k, 0.1 power x, 0.1 power y. These will cancel under this and this. We will have 9 is equal to 3. Yeah, this will be 3 power y only. So that means you have y as 2. Okay, so let's divide now equation 2 and 3. Dividing 3 by 2, you have 2. It was 2.7 into 10 raised to power minus 3 upon 9 into 10 raised to power minus 4 is equal to k into this upon k into 0.1 power x, 0. This will cancel, and there will be some more cancellations. Here you will have 27 upon 9 into 10 raised to power minus 3. This will be 10 raised to power minus 3 as well, because I have dissolved this decimal, and the 10 will come in the denominator. This is equal to 3 power x. So they will cancel at 3. This is equal to 3 is equal to 3 power x. That gives you x is equal to 1. And that's what we needed to find out. What we needed to find out was order of the reaction with respect to A and B are respectively. So the order of reaction with respect to A is 1 and with respect to B is 2. That makes option A to be the right answer. Hope you got that. Next is question number 145. The correct statements about zeolites are the number 1. They are good shaped selective catalysts. This is absolutely right. Correct. They contain aluminium, oxygen, silicon framework. Yeah, this is also correct. They are not found in nature. No, they are found in nature. They are used as catalyst for cracking hydrocarbons in petrochemical industry. This is also correct. So, zeolites are good shaped selective catalysts because of their honeycomb-like structures. They are aluminosilicates with three-dimensional. They are aluminosilicates with three-dimensional network of silicates in which some silicates are replaced by aluminium, giving rise to this network, this framework. They are generally found in nature, so this is wrong. The third one is wrong, and are widely used as catalysts in petrochemical industries for cracking the hydrocarbons. So you have option D as the right answer. Hope you understood this. Next is question number 146. Which one of the following is not the application of adsorption? Use of silicon oxide gel for removing the moisture. No, this is correct. I mean, this is used. Next, the use of coconut charcoal to separate inert gases. This is also done. Use of aluminum oxide to separate the components of organic mixture in chromatography. This is also correct. The next one, use of calcium chloride for removing the moisture. No, the use of calcium chloride for using the moisture is an application of absorption. This is an application of absorption, not adsorption. So option D is incorrect. Hope you understood this. Next is question number 147. How many of the following can be purified by using zone refining method? Nickel, okay, all these things are there. How many of the following can be purified using zone refining method? See, zone refining method is based on fractional crystallization. Fractional crystallization. It is because it impurifies is because impurities refer to stay in the melt form, and on solidification, only pure metal solidifies on the surface of the melt. So metals like silicon, germanium, gallium, boron, and this of high purity are purified by this method. That makes option D to be the correct answer. Question number 136, you have to match the following. So you have list A, group 13 element, and list 2 contain their metallic radius PM. See, these options are not the exact figures of it, but all these group 3 elements, they have the radius. This follows the order of first is boron, then is GaAl, and that is aluminium, then you have lanthanide, then you have thallium. So this is the order. Looking at that, your option A matches with the aluminium. This is like, first of all, you have the gallium. This is having the smallest one. So this matches with the this. And then you have aluminium with option 2. And then this is lanthanide. This is this and this. So they are the correct pairs. Option B is the right answer to the question. Hope you understood that. Let's move to the next question. Question 447, how many of the following can be purified using zone refining method? These are the list given and you have to choose which can be purified using a zone refining method. First is, what is zone refining method? This is based on fractional crystallization. Zone defining method is based on the fractional crystallization. This is because impurities prefer to stay in the melt form, and on solidification, only pure metals solidify on the surface of the metal. Metals like this silicon, gallium, germanium, lanthanum, and what else? Boron. These can be purified using zone refining method. So you have these as 5. That means option B stands to be the correct answer to the question. Hope you got that. Next is question number 148 for ozone molecule. Consider the following. It is a linear molecule with bond angle of 180. Okay, and B says it's an angular molecule with the bond angle of 117. Then C is bond length of both O bonds are same with respect to oxygen. It is thermodynamically more stable. All right. So first thing, it's a linear molecule with a bond angle of 180. This is wrong. Ozone is having an angular angle of 117 degree. It's an angular molecule with a bond angle of 117 degree, and both the OO bonds, they are equal. And with respect to oxygen, it is less stable. So this one is wrong. See, what is ozone? If I make ozone molecule looks something like this. O and this thing. So this is having the negative charge. This is the positive charge. This angular angle is actually 116.8 degree, and this length is 1.278. Right? And it's an inorganic ozone, which is O3. This is trioxygen. This is an inorganic molecule. Inorganic molecule with the chemical formula O3. It's a pale blue gas with distinctively pungent smell. It's an allotrope of oxygen, which is much less stable, not more stable. It is less stable than oxygen, breaking down into the lower atmosphere to oxygen itself. So you have B and C as the correct answers. That makes option A to be the right answer. Hope you got that. Let's move to the next question. Question number 149 from the list given below, the number of lanthanides which exhibit +4 state in their oxides is which of these? Okay, the first one is this is praseodymium. This is having the atomic number of 59. This is a lanthanide which exhibits +4 state in their oxide. The next one, neodymium. This is having the atomic number as 60. This also exhibit the same state. Then you have terbium and dysprosium. These two also exhibit it. So these two, this is having the atomic number of 65, and this is having atomic number of 66. So all of these show +4 state in their oxides. That makes option B to be the correct answer. Next is question number 150. Given below are the two statements. First one, all copper halides are known except the iodide. The reason for the same is copper 2 plus oxidizes iodide ion to iodine gas. Okay, let's read the first assertion. It says all copper 2 halides are known except the iodide. Yes, that's true. See, because copper 2 plus, this is true because copper 2 plus this iodizes um oxidizes iodide item iodide ion to iodine gas. I'm repeating this. Assertion says copper 2 halides are known except the iodide. This is true because copper ion oxidizes the iodide ion to iodine gas. How is this done? This is done like this is the equation. For iodide ions, this makes copper iodide. This is in the solid form plus the iodine gas. So this is the equation. That means both are correct. That makes option A to be the right answer. Hope you understood that. Next is question number 151. Monomers of nylon 2, nylon 6 are. Okay. See, monomers of nylon 2 and nylon 6 are glycine, which is given by H2N CH2COOH and aminocaproic acid, which is H2N CH3 CH2 5 COOH. The structure of these monomers are given here in option C. So we have this as the answer. Next is question number 152. Given below are the two statements. First one says assertion A, hydrolysis of DNA does not form equal number of A and T, G and C. Reason says in DNA, adenine forms hydrogen bonds with thymine and cytosine forms hydrogen bonds with guanine. The correct answer is which of the following? See, the hydrolysis of DNA does form equal number of A and T and G and C. So the assertion is incorrect. And the reason says also in DNA, the adenine forms hydrogen bonds. Okay. See, in DNA, adenine forms hydrogen bonds with the thymine and the cytosine forms hydrogen bonds with guanine. This is correct. The reason is correct, but the assertion is wrong. That makes option D to be the right answer. Next is question number 152. The structure of glyala is which of these options? Let's see the options properly. Okay. So, see, glyala is a dipeptide of glycine and L-alanine. Its structure is given by this B option. H2N, here is ONHCOOH. So that makes option B to be the right answer. Hope you got that. Next is question number 154. It says the group present in prontosil is. Let's make the structure of prontosil first. The prontosil looks something like this. So this is the structure of prontosil. Over here, you have this. It contains this group. That makes first option to be the correct answer. Hope you understood that. Next is question number 155. The optically inactive compound from the following is. So you have 2 propionyl, 3 bromopropionyl, 3 bromo, 2 idiopropionyl, 2 bromo, 3 iodopropionyl. These are the options. The optically inactive compound, which of these is this? See, if I draw this 3 bromopropionyl, this is optically inactive compound as among all the 3 carbon atoms, no carbon atom is chiral. Let's make the structure of it first of all to understand. So here is your boron C, 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 H, double bond O, here is H, here is again H, H, and H. This is 1, 2, and 3. You can clearly see that among all the 3 carbon atoms, no carbon atom is chiral. No carbon atom is chiral, thus it cannot rotate a plane polarized light. So here you have option B as the correct answer. Hope you understood that. Let's move to the next question. Question number 156, which is the correct option for the following reaction. So this is the reaction. Let's see what will be the products of the reaction. This is 2CH3, CH2Br in the presence of sodium and dry ether. This will give you CH3, CH2, CH2, CH3 plus 2 molecules of sodium bromide. Yeah, this is your Woods reaction. And what is that? What is Woods reaction? It is it's an organic chemical coupling reaction wherein sodium is reacted with two alkyl halides in the environment provided by a solution of dry ether in order to get a higher in order to get a higher alkane along with the compound containing sodium and halogen. Containing sodium and halogen. So therefore, the right answer to the question is your option A. Hope you understood. Next is question number 157. The number of products obtained in the following reaction is. Okay. See, in this particular reaction, when aldol condensation is carried out between two different aldehydes and or ketones, having alpha hydrogen atoms, it is called cross aldol condensation. Here, since both the reactants contain alpha hydrogen atoms, it gives a mixture of 4 products, and that will be given by, you have to look at carefully, this will be given by, in the presence of sodium hydroxide, heated in the presence of sodium hydroxide, here you will get CH3, CH2, CH2, CHO. Here is OH from 2 molecules of ethanol, from 2 molecules of ethanol, and this will also give you C6H5, CCH2, COC6H5. And you have one OH over here and OH3 over here from 2 molecules of question number 156, which is the correct option for the following reaction. So this is reacted with sodium and dry ether. It will give you the products as CH3CH2, CH2, CH3 plus sodium bromide, 2 molecules of over here. Yeah, so that's it. Right. Now, this is what? This is Wood's reaction. And what is Wood's reaction? This reaction is an organic chemical coupling reaction wherein sodium metal is reacted with two alkyl halides in environment provided by a solution of dry ether. Solution of dry ether in order to form a higher alkane along with a compound containing sodium compound containing sodium and halogen. So you have option A as the right answer. Hope you understood that. Next is question 157. The number of products obtained in the following reaction is. Let's complete it. So here you have C and this is CHO. This is ethanol. And here you have this. Here you have C. This is C. And you have wait. Okay. You definitely have a C over here and a C over here. So here C to complete this will be CH3. Now this is heated in the presence of sodium hydroxide dilute to sodium hydroxide. This will give you first of all CH3, CH2, CH2, CHO hydroxyl ion over here from two molecules of ethanol. Ethanol. So, and this will give you C6H5, C, CH2, C, C6H5. Here you have OH, OH3 and ketone. Yes. So from two molecules of acetophenone. This is aldol condensation. And two more products will be there, which is C6H5C, CH2, CHO. Here you will have OH, CH3 plus C6H5CO, CH2, C, Cl, OHH. This is cross aldol condensation. Cross aldol condensation. See, when aldol condensation is carried out between two different aldehydes or ketones having alpha hydrogen atoms, it is called cross aldol condensation. Here, since both the reactant contain alpha hydrogen atoms, it gives a mixture of four products, which are listed over here. So you have four products. Option D is the right answer. Hope you got that. Next is question number 158. What are X and Y respectively in this particular reaction? So let's complete the reaction first. You have C6H5CHO2 plus this. This in the presence of hydroxyl ions at 293 Kelvin. This gives you X. This is C6H5CH, which is CHCO C6H5. This is your X. And then this is further reacted with this reactant, and you have the Y as C6H5CH, which is equivalent to CHCHOH C6H5. This is your Y. So looking at this, you have this as the right answer, option C. Hope you understood. Next is 159 question. Which of the following is used in perfumery? Okay, in perfumery, esters of benzoic acids are used. They give a very pleasant smell. So we have first option as the right answer. Next is 160 question. This is the last chemistry question of this paper. Arrange the following in increasing order of their boiling points. First of all, you have N-ethyl ethanamine and butanamine. Then you have N-dimethyl ethanamine. See, as the number of hydrogen atoms on a nitrogen atom decreases, the extent of hydrogen bonding also decreases. Due to this, boiling point of the compound decreases. Thus, the correct order will be first will be like very first one will be the second option, then will be the first, and then will be the third. That is, you will have butanamine, this followed by N-ethyl ethanamine, and then you have this. Okay, third option. So that makes this as the right answer. Option D is the correct answer to the question. So students, with that, we have completed all the chemistry questions of this paper. Hope you understood them well. And don't forget to watch our physics and mathematics portions also. Students, for a better preparation, you must download our app and you must visit our website www.examsnet.com. There you will find these tools will be very helpful to you in preparing for your entrance exam question papers. You will find a number of PDF solutions of this paper and multiple entrance exam question papers of similar type. A very best of luck. Keep shining, keep rising high. That's all for this paper. Bye.